All right, so we're gonna, in the assets, we've created a scripts folder, and we're gonna click on our sphere. We're gonna add a component, and that's gonna be our new script. We're gonna call the script PlayerMove, and make sure you're really careful with the capitalization. You want all lowercase letters, no spaces, except for that M, and you do want a capital M there. And make sure the language you choose is JavaScript. If you click on your assets, you should see your JavaScript script there. Click and drag it into your scripts folder. And then click back on your sphere. So now, in just a moment, we'll be editing this script. But what we want to do before then, we want to add a component. And so to do that, I'm up in my top menu here, component. I'm adding a physics component, a rigid body. And what this is going to do is it's going to allow us to apply physics onto the sphere. It allows for physics manipulation without us having to code that physics manipulation. So things like gravity, mass, these are going to affect our object without us having to code that. The rigid body component allows us to manipulate the ball with forces as well, where we can code, we can create forces and apply them to the ball, and the ball will react like a ball would in real life. Forces can be thought of as a push or pull that have a certain direction as well as a certain magnitude or size. So in our code, what we're going to do is we're going to set up the size by establishing a speed variable, and then we're going to set up the direction of the force using what's called a vector3 object, and we'll get into that. Okay. So go ahead and in your scripts folder, double-click PlayerMove, and it should open MonoDevelop. And this may take a little bit of time. Don't get frustrated. Be patient. You'll see that in Unity you can preview the script, but you can't edit it. When you double-click, MonoDevelop should open for you. And this screen will open. Don't click anything, not until you see this screen here. So it starts with some sample code, but we can actually delete all of this except for what's in line 1. Line 1 prevents Unity from doing very aggressive auto completion. It will try to guess what you're typing to some extent, but we want to leave this line 1 in, and that will be helpful for us. And the first thing we're going to do is set up a class with the same name as our file. And that's why I said to be so careful with capitalization, because this is only going to work if you have the same name of the file. Okay, so we are making a class for this script, and it's called PlayerMove, all lowercase letters except for the M. And these keywords extends mono behavior. What this is saying is you can, this class is going to be kind of an offshoot of mono behavior. And mono behavior is actually the base class for all scripts. So it will inherit, this class will inherit the properties and functions, methods associated with mono behavior, that base class. Okay, now like I said before, a force can be thought of as a push or a pull in a certain direction. And when we're talking about pushing our sphere, however fast our sphere rolls is going to be the size of our push. So here we're going to set up the speed to be 800. And note that I have that 0.0. That means that 800 is, that's a floating point number. I have my var keyword saying that we're establishing a variable. Speed is what I'm naming this variable, and we're assigning it the value 800.0. That's going to be the size of our push. If I wanted it to be a pull, what do you think I would do? I would make it negative, but we're not going to worry about that too much right now. a push you can think about as like in the positive direction, and that is positive. Okay, so we're going to add something that's called a function update. It's in here, and we're not creating update. This is a function that comes with Unity. And basically, you can think about it acting in a similar way as the forever loop in Scratch. It's going to reset continuously, constantly as the code continues. All of the sequence of code put between these curly braces are going to iterate several times every second, and many times a second. All of the lines in this are going to be run. So note that this is within the curly braces for our class. So we set up our function update there. Again, you can kind of think of it like a forever loop. And inside our function update, we're going to write the first line that gets input from the user. We're creating a variable called horizontal, move horizontal. Note my capitalization there. And this variable is going to be of type float, which means that this variable is going to store floating point numbers. Okay, so this variable, which is going to store floating point numbers, we're saving this value to this variable. Now this value we know is going to evaluate down to a floating point number, but what number is this going to be? Well, what this is saying is listen for input from the user. So we can think about these as being like these blocks from Scratch. It's listening to see if the user is pressing the right or the left arrow key. So why this string horizontal? And what floating point number is it going to mean if the right arrow key is pressed or the left arrow key is pressed? Well, let's go to our Unity preferences. So we go to Edit, Project Settings, Input. These are built-in input that Unity uses. We didn't create these for this project. These are the standards like WASD and the arrow keys. And the way that they're sorted in Unity is by axis. So if you want your object to move left or right or on the horizontal axis, the keys that Unity has set up to do that are the left arrow key for the negative button to move the negative X direction, and the right arrow key for the positive button. They also have alternatives. The A key on your keyboard for the left to move left on the axis, and the D key on the keyboard to move right. So you actually can't automatically use those, right? If I try to just move after pressing play, I can't do that automatically, but let me bring that back. I can access these by using this line, right? I can say get access horizontal, and this string refers to this string here, this horizontal here. So what this is saying is basically check to see if the user is pressing either the left arrow key or the right arrow key, or no arrow key. Those are your options. They're either pressing the left arrow key, they're pressing the right arrow key, or they're not pressing either. And this is going to evaluate to a floating point number. So if the user is pressing the right arrow key, this evaluates to +1. If the user is pressing the left arrow key, this evaluates to -1. And if the user is pressing neither, this evaluates to 0. To move forward and backwards, we're going to do something very similar, except using the quote-unquote vertical axis. And that's a little confusing because we're really describing forward and backward movement, not up and down movement like you would imagine jumping. But the string, hold on. The string that Unity uses to capture that up and down movement is called vertical, not forward. So that this is not going to make our ball leave the ground. It's going to make our ball roll forward or roll backwards. So again, we're storing a floating point number to this variable that we created called move vertical. If the user, when this line is run, which remember is multiple times per frame actually, it checks to see if the user is pressing the up arrow key or the down arrow key. If the user at that moment is pressing the up arrow key, +1 is saved to move vertical. If at that moment the user is pressing the down arrow key, -1 is saved to move vertical. And if at that moment the user is not pressing either the up or down arrow key, 0 is saved to this variable. Remember that these lines update continuously as the game continues. So it's, as soon as the user presses the right arrow key, move horizontal is not going to be 1 for the remainder of the game. It's going to check again, and as soon as the user picks up their finger, move horizontal will return to 0, which is its state when no key is being pressed. So we're going to use these variables to set the direction of our push or pull. And we're going to do that by saving them to a new variable. And this variable is a vector3 object, not a vector3. Okay, so this line here, we created a variable called movement, and we're saving a vector3 object to it. And let's talk a little bit about what a vector3 object is. A vector3 object is a representation of a 3D vector, and that just essentially means that it's storing information regarding x, y, z coordinates. Remember, x coordinates describe left to right movement, y coordinates mean up to down movement, and z coordinates mean forward backward movement. Sorry about that. As the game continues, movement is going to constantly update, and what it's doing is it's pointing the direction in which our sphere is going to experience that push. Think about basically having your friend, right? And you are planning where you're going to give your friend kind of a playful push. You're planning where you're going to stand around your friend to give them that push. If you want them to fall or kind of stumble just to the right, you would push them just to the right. You would stand kind of on their left side, push just to the right. So you have to have the size of your push. You want it to be playful. You don't want them splayed out on the ground. But you also have to choose the direction in which you're going to push them. If you wanted them to move just forward, you wouldn't push them to the side at all. This would be 0. And you would push them forward. This would be 1. But you could also push them diagonally. And that would be like pushing them to the right, but also pushing them forward. They would fall diagonally. And that's just like what our sphere is going to do, it's going to experience diagonal movement sometimes. And that's when the user is both pressing the up arrow key and the right arrow key. So that move horizontal is 1 and move vertical is 1. Or let's say if they're moving backwards horizontally or to the left horizontally, then move horizontal would be -1, move vertical would be 1. Right, movement is going to constantly change value. When the right arrow key, if just the right arrow key has been pressed, then move horizontal will be 1. But then on the Y and Z axis, you're not going to see any change. If they're pressing the left arrow key and the up arrow key, move horizontal is -1, move vertical will be 1, and they'll be moving this way. Now, notice that the Y-axis is always 0. That's coded in there. That's because right now our ball can't jump. And that's what manipulating the Y-axis would look like. It would look like a jump. And you actually could code that on your own. What you would have to do is add a line below move horizontal and move vertical, and you'd have to define a variable. You could call it var move up of type float, and you would use an input.getAccess line, and your string that you would be listening for would be that spacebar key, so the string would be jump with a capital J. And instead of having a 0 for your Y coordinate in this vector3 object, you would have move up or whatever variable that you define. So you can try that as an extra challenge on your own. We're not going to do that today. All right, we're going to add one more line. And this is, so here we're setting up the size of the push. Here we're listening for input. And here we're setting the direction of the push based on this input. This line that we're about to add actually adds the push. That's where the push actually happens. So we're going to access the rigid body component of our sphere. And we're going to add a force to it. And it's going to be the direction of the push times the magnitude or size of the push. And then we're going to add this time, delta time. We're not going to spend too much time talking about what this does, but this pretty much says the amount of time that you give this push. All right, I'm going to save this, and let's see what happens. Ooh. Oh, looks like I need to capitalize my B there. Sorry about that. Make sure you use that U. This is the British spelling of mono behavior. Oh, goodness. Oh, another syntax error there. I need my parentheses after rigid body. So I added the capital B there, and now my parentheses. And now it should work. Make sure you're paying attention to this screen, your game tab, and not your scene tab when you're playing, because this side's pretty misleading. Okay, this is super important. Heads up, super, super important. I'm playing my game right now. When you are done testing it out, you have to click on this play button again so that you're no longer playing. Don't just click on the pause. You have to click on the play button again. And the reason that is, any change that you make while the game is being played will not be saved. Absolutely not. And let's look at an example of that. If you click on your sphere object in the hierarchy window, you'll notice that you can actually, you see speed, variable speed that you set, you can actually change it. So I could make my sphere's speed down to 400 and see what that would do. So I change it here, I hit save, and now I press the play button, and my sphere rolls a little bit slower. While the play button is still being, I can unpress the play button and it stays at 400. I'm going to press play button again. I could try with the game running to change the speed, let's say, to 45. And I see that my sphere is rolling, but very, very slowly. But that change that I made does not get saved once I hit this play button again. It returns back to 400. Any change that you make while the game is running will not save. Okay, so I can change my speed. Let me change it back to 800. But I created several variables in my game. I created move vertical and move horizontal and movement, and I can't access or change any of those from this screen. The reason that is the case has to do with something called variable scope. So you defined speed outside of the function update. You defined it within the class, but outside of function update, you defined the rest of your variables inside of the function. Any variable assigned inside of the function is not going to be accessible. And you can see that here. I have speed, and then I defined message 1 and set it equal to a string, and message 2 and set that equal to a string. Well, here you can see that once I made these changes, message 1 was available, but message 2 was not, and that's because message 2 again was inside of the function, message 1 was outside. Okay, we're going to add one more script here. We're going to get it so that the camera follows the sphere around as the ball moves. And to do that, the first thing we have to do is move our camera up and rotate it down. And I've actually already done that for you all, or on mine. So go ahead and change the position of your camera, camera here, to be 0, 8, -5, and the rotation to be 50, 0, 0. And the next thing you're going to do is you're going to add a component, a new script, and call it camera follow. Make sure you're careful with your capitalization there. You want all lowercase letters except for that F. You want it to be JavaScript. If you click on your assets folder, camera follow is there. Click and drag it into your scripts folder just to keep everything nice and clean. And then double click camera follow to open it in MonoDevelop. Again, you start with this sample code. We're going to go ahead and delete it, but leave that first line. And then you're going to create that class with the same name as the file name. So camera follow, no space, all lowercase letters except for that F. And again, it's going to extend mono behavior, but we're going to spell it correctly this time, or with the right capitalization. So again, this just means that it's going to inherit the properties and functions methods built into every initial class. The first thing we're going to do, we're going to define two variables. We're going to define a variable which is going to be of type GameObject. Let's capitalize that O as well. This is going to be our reference to the, in this case, the sphere. It's the reference to the game object that we want the camera to follow. And we're also going to create a private variable, which is another example of variable scope. It just means that other game objects won't be able to access this variable. And this variable is called offset, and it is going to be a vector3 object. So you can think about private variables as being like in Scratch when you create a variable that's just for this sprite only and not for all sprites. Okay, so essentially what we're doing with this code, we're going to set it up so that at the start of the game, we're going to get the camera's position. And that is essentially going to be, since the camera and the sphere are always going to start in the same positions, if we get the camera's position at the start of the game, then we can kind of tell the distance the camera will be from the sphere. So here I added something called function start. Again, start is a built-in function for the game, but this within its curly braces, you can kind of put the sequence of code that you want run at the beginning of the game. Here we're going to set offset, the variable that we declared above, to be, to be the position of the camera. Since this script is attached to the camera, what it's going to do is it's going to access the position. Think about how in the inspector window, you put the position in that transform box. Right, transform position. And so that's what it's doing. And it's actually, it's a vector 3 object, right? So it's going to be parentheses 0, 8, -5. And then we're going to add another function update, but this time instead of just function update, which is run many, many times a frame, this is only going to be run, this one's called function fixed update, and it's only run once per frame, and that's going to help us for smoother movement. No, I'm sorry, it's not fixed update, it's late update. We'll see fixed update later on. And here it's going to set, it's not going to read the position of our camera, it's going to set the position of the camera to be wherever the player is, plus that offset from the beginning of the game. So it's saying however far away wherever the camera is here, essentially in relation to the sphere, as the ball moves, continuously have the camera be that far away from the sphere. So it's setting the position of the camera to be wherever the player is plus the offset. And we know that this is really getting the distance from the sphere because our sphere starts at essentially 0, 0, 0, really 0.50, but the center of the world. So this camera is really in relation to our sphere here. Remember that player is a reference to, is a game object reference. So go ahead and save this. But right now, Unity doesn't know which game object we want player to be. So in their main camera, what we actually have to do, notice that this box came up with player. We have to click on the little circle, tab over to scene, and select the sphere as the player game object that we want to reference. All right, then go ahead and hit the play button, and it should work. You should be able to follow the camera. Don't forget to hit the play button again to stop, and I hope you enjoy your code, and I will see you guys next for lesson 3.